Hello, ladies and gentlemen. Welcome to this new tutorial about how to make a grid or tile-based movement in a 3D space in Unity. So what we're gonna do in here today is actually we check out how a grid is actually be recognized and how can we move like between those two tiles and how do we define the, let's say, size of a grid whenever we have a grid or even not. It depends. So what we want to do is we want to use this little bomber girl. I have used that yesterday inside the 8-way movement system where we're talking about like when we're moving like a 45-degree angles and stuff like that. So feel free to check this out as well. And also, once again, we gonna maybe animate her as well as we did yesterday. So by creating an animator component and all the other things, and connect her to it. So I deleted everything from yesterday, and we are starting basically from scratch since this grid-based movement is going to be a bit different. So what do we need to do is, of course, we need to write a script which is taking care of all the movements and the 4 directions we are able to go to. Since when our little bomber girl, my little bomber girl is going to be, let's say, in this little grid. Oh, let me show this one. In this little grid, like in the center, we want to make sure that she's only able to go left, right, up, and down, and also rotates in the correct direction. So that's what we're gonna do today. I want to look into. So I go to my not existing scripts folder and create a new C# script. And this is going to be my movement for today. So once again, if you have created any other movement once, you probably want to rename it different. It doesn't matter as long as it later on is connected correctly to your movement stuff. And we're going to open this one up in MonoDevelop or Visual Studio as you please and like and whatever you're working with. I resize it a bit so you can see stuff better in just a moment. And I zoom in, of course, as well. So what we need is, of course, we need update. Of course, we need start. So I just get rid of these arguments here or these commands. So speaking of direction, at first we need to have a vector or several vectors which are determining where the character at the moment is, where it is looking at. So the looking at is going to be performed a bit later on, but basically, well, actually we're gonna do it all at the same time. So let's start with that. At first, we need a vector, and it's going to be vector 3 since we are in the 3D space. We might not use the y value, so the height, but still we are going left and up basically, so on the x and on the z axis. So, but this one is going to be like a direction vector at first. So we create a vector, we name it up. Then we say equal to, and now we set it to whatever it is going to be. In this case, it's vector 3 dot 0. So what we can also now do is we can set a comma over here next to it, and we can create more vectors like in one of the same vector related to it. So we can, for example, say now it's the next vector is going to be the right vector. So it's the same type, vector 3, and we set this one right is going to be equal to a new. Now we say vector 3. And then in open close parentheses, we set the correct direction or rotation vector in this particular case. So we say 0 for the x, comma, then we say 90, which is going to be, once again, the right direction, comma 0. What we now can do is also we set another comma over here, and we take maybe down at the next one. So we have a down vector. So down is equal to a new vector 3, open close parentheses, and inside we say 0, comma, and I believe you already know what's coming next. 180, of course, comma 0, because it's when we are looking upwards, we are looking in the Z direction when we are starting, like pointing away from the actual camera. And down is like 180 degrees rotated on the Y value, so it's related to our character, of course, wherever it is currently looking. So the next one is going to be left, so we say left is equal to new vector 3, open close parentheses, and I believe you already know what's coming next. Of course, it's 270 because we are rotating clockwise all over the place. Then we say comma, and now we have another vector which is going to be our current direction. So current or direction, you can type it out whatever you please and like. And this one is also a vector 3 dot 0. It's going to be like the vector 3 dot up. So that's what we currently or what we can use at the very start to set our position correctly. Or let's say not the position, but the rotation. Then we need 3 different other vectors. So I create another vector 3 over here. Another way to create vectors is like writing them in one line, but don't initialize them to anything, so they will stay whatever they are, like 0, 0, 0 at the very beginning. Okay, so what we need is we need a next position, which is going to be the position where we want to go to. So we say next POS, comma. Then the next one is going to be the destination vector, which is going to be basically the next position, but we are changing that according to where we are coming from. So the destination might change here and there before we are setting next position, basically. And then, of course, we have a direction, which is going to tell us in which direction we are actually looking. We could use a quaternion, but actually vectors are rather simple in cases of rotation. So we only talk to the direction based on where we are currently going through. Also, by the way, we are doing the movement with the keyboard, or maybe something like ASD or something, or W, as well as probably the arrow keys. So if you want to use swiping and all the other things, it's absolutely possible as well. Just change the input types later on. So that is for that. In start, I want to initialize that current direction is going to be set to be equal to up. So as you can see, up is just another vector in the same case. So we can now change current direction to be just whatever the vector names are. Like current direction is equal to up or right or down left or whatever, or even itself is going to be 0, but still 0 doesn't matter since once again we have the up vector, which is representing the same. So that's what we want to initialize at the very start. Also, what we want to say is what next position is. And the next position is going to be equal to vector 3 dot forward. So we are always moving over the forward axis, of course. And what we also want to set is the destination. So the destination is the point where we are currently at. In this case, transform dot position. So we actually don't really move because destination does not have any, let's say, new input. So the next one, we need some speed later on. We're gonna increment these later on, I guess. And let's create a movement, or the actual movement when we are doing like these inputs like ASDW, whatever. So void move, open close parentheses. We're gonna call this from update anyways. Now open close curly braces in here, and don't forget to keep everything organized. In here, we just call move, open close parentheses. We can also do some stops or some bool to protect move, but actually, for the moment, we just don't need to do stuff like that. Okay, when we are start to moving, we want to set our transform.position to something. That's the very first one. We can do this in the end or in the start, I believe, so basically it doesn't really matter. What we want to do is we want to move towards a position. And in this case, we can say or make use of the vector3 dot move towards. This is an implemented or increment. Yeah, it's a function which is already present in Unity or is based on or a part of mono behavior, so nothing fancy at all. So where do we want to move? At first, we need to know where we are currently at. It's going to be transform dot position. Where do we want to go to is, of course, the destination. So we're going to put in destination over here. And then we want to create a value which is defining the speed. How fast do we want to go there? So we can say speed. I don't have that. And of course, we implement time.delta time. So whenever we have different devices, the speed is always the same. And since I don't have speed, I probably create the speed variable pretty quick over here. So it's of type float. Call it speed and give it a speed of maybe 5. You can do this private or public, however you like to. I keep them private for the moment, so I just need to do stuff inside the script. Otherwise, if you want to have access in the inspector, you can make this one public as you please and like, whatever. Now we need all the inputs like the ASDW keys and all the other things, so we can actually set the correct destination as well as the correct rotation. So let's do that. So the usual one, as you already know, is if input dot get key down. What we can do is we can press any keys of our whichever we are pleasing and liking. We're gonna take key code. Let's start with W. Key code dot W. So W represents the up direction. So key code dot W. And we can also use an arrow key, for example. So we can use two pipes. So we say OR, which is representing an OR operator. Or we're gonna do another input. I'm gonna copy this part over here and paste this in here since I have to do this several times. Or I'm gonna take the arrow up or up arrow in this particular case. So key code up arrow. So one of these inputs are going to change two, or no, three things actually, or maybe two. I don't know. At first two. So what we want to set is the next position is going to be equal to vector3 dot forward. Since we are looking upwards, or we want to go upwards based on the world direction, or world direction, I would say. We're gonna use vector3 dot forward in this case, since we want to go once again over the forward axis based on the world arrangement. Then we want to set our current direction, and the current direction is equal to up, since once again we are rotating our character into the upward direction. There's one more thing which we gonna make use of probably later on. Which is going to be a variable, which is checking if we are even able to move, like when there's a wall and stuff. What we're gonna implement this in just a moment, I believe. So I copy this complete part, and I need to do this like another 4 times, or 3 times in this case. So next one is going to be the down direction. So for example, here we're gonna use the S key. Here we're gonna use the down arrow. What we want to have in here, vector3 dot back. So we want to go backwards, based once again on the world direction. Then we also set the current direction to be down. Then we're going to take the next one, which is going to be, let's say, right. And right is going to be the D key or the right arrow, like this. And what we want to set is the vector3 dot right. And the direction, the current direction, so the rotation is going to be right as well. Then we're going to have the left one is also where we're going to make use of the A key or even the left arrow. Pick that from the list. And vector3 dot left is also represented here. Oh, only one of that points. And of course, our current direction should be left, of course. So what we now have is whenever we are doing some inputs, we're going to rotate and move forward, or actually move in or set the next position to be left, right, up, down, whatever. But since we are not using or making use of next position inside that destination yet, we are actually not moving, but we are rotating. We can also test this out pretty quick if you like to. So I'm gonna go here, take my Bomber Girl, and bring the script movement onto her once the compiler is done loading and running, whatever. There we go. There are some private fields which we are currently not using, but that is fine. So let's test this out. So when we are once again in update and we are pressing right. Oh, nothing is happening. Why? I have no idea. Probably we are not taking any, we don't care about the rotation even yet. So even that is not working at the moment. So we are just setting the current direction to be whatever the direction is, but we don't rotate at the moment because we don't have any input for that. So that's what we're going to do right now. Okay, so whenever, let's do the movement first, or do we do the rotation first? Basically, we do both at the same time. Okay, so whenever we are inside the movement, and we are doing the movement, and we're doing the inputs, we want to see where we are currently at. So I'm gonna leave a bit space here. So what we want to check at first is how big is the distance between our current position and the destination. So what we say, or what we make use of, is vector3 dot distance, which once again is also another implemented function over here. So we want to measure the distance between our destination, which we currently have set in start to be the transform dot position, and our current position, so transform dot position. And what we want to measure is how big that is. And if it is smaller or equal to a super small number like 0.00001f or something like that, can even be bigger. Well, just don't make it too big. But it has to be rather small. If that is the case, then we want to check if we are able to do input basically. That means we have completed one step, like because this destination has been reached, and only then we are actually able to do a destination update and a direction update. But as this is only working, well, hopefully, I mean, it will work even no matter what. But what we want to do at first is we want to rotate ourselves at first. So when that is the case, we want to make sure that our transform dot local Euler angles, this is the part for the rotation, is going to be equal to the current direction. So whenever we are at the correct spot and we are doing this input, we want to make sure that current direction is going to be, rotated, or actually the local Euler angles, like the rotation of the object, is going to be set or settable to be in the correct direction or in the current direction. So now we should be able, since we are on the spot, also on start, we should be able to manipulate the direction right now with the arrow keys. Let's test it out. So this is right, this is left, this is up, and this is down. So we can now, with the arrow keys or with ASD keys, we can at least already look into the correct directions. Okay, cool. So now we can actually also update the movement, but we want to do a check if we are actually able to move. Maybe we're gonna implement this a bit later. I mean, we will do that, but maybe we try to do stuff like, okay, we're gonna set, because we already reached our distance, we set our current destination is going to be equal to our current position, and now we add next position to it. What do you think about that? Of course, whenever we are trying to reach the destination, we should now be able to, just with that two lines, rotate in the correct direction, like with an instant rotation. There's no looping in between that, as we have done yesterday in the 8-way movement, but it doesn't matter for the moment, since we are now able to update the destination based on our current position and put onto this the next position. When we now press play, we should be able to move like one step to the right, or actually we can change those. It's keeping on going left and right, but still, as you can see, it is going, or the character is only going on the grid. It's like always doing that updates whenever, it has reached the distance correctly, or the destination correctly, because we are moving like the next position is always 1. So we have a grid based movement right now in a, like within the size of 1 by 1 by 1 into the grid size. If you want to have another grid size, you can later on, of course, change that, multiply that, whatever, to your needs. So for smaller grids, for example. Okay, so the next problem is we maybe don't want to have it like constantly moving. And that's where we're gonna have to do some blocking. So actually we need to wait until we are able to do the next input, I would say. How can we do that? At first we need to encapsulate like the complete movement here into an if statement. So at first we're gonna say if, we need to create a boolean for that. Over here, like bool can move. We don't need to set this one because we need to have this one at the beginning to be false anyways. So if can move. If that is the case, only then we are able to go to our next destination. And we can set move or can move always to be true whenever we are doing one input, like whenever we are setting a key down. And this is like a one-time input. So what we can say here is now can move is equal to true. Otherwise, we are unable to move, right? So we copy that and put this like in every other one input over here as well. There we go. So whenever that is going to be the case, we are going to set this to be movable in that particular case. And what we now want to do is we need to set the possibility to stop as well as check if there is some kind of a wall in front of us. So what we're going to do is we create a boolean, a bool function, which is checking for us, sorry for the typos, valid. I call it valid. And what we want to check is, of course, what is the next position, basically, is that valid or not? We can do it like a different ways. We probably don't even need to check the next position in that case, because we always shoot some kind of, we're going to shoot a raycast into the direction where we are looking to. And then according to this, we are going to update can move, basically. And we can like go and get something like true or false if we are able to move to the direction where we are pressing on or not. So once again, if there is a wall. What we're going to do at first is we create a new array. It's going to be just a temporary array, which is just called and created whenever we need it. I call it my array is equal to a new. Now when you create a new array, and open close parentheses, and inside we want to take the current as origin. It's going to be transform.position plus, and now we need to lift it up from the ground, otherwise it will go through or under walls, which we don't want to. So we need to add some lift up a bit. So I add up a new vector 3 and lift it up like a small amount on the y-axis. So plus new vector 3, 0 on x, comma 0.25f maybe on the y value. So we just lift it up from the ground a bit, since our pivot point is going to stay on the center. Well, usually. But once again, it can be can or will happen that this ray is slipping under the walls or through the walls. And so on that axis, we don't add anything. Then we need to put in the direction. In this particular case, it's always the forward direction. So the current, so transform.forward, which is related on the the actual game object and not to the world, but once again to the game object. Then we need to raycast, which is actually pointing into one direction and give us feedback, or in this case a raycast hit. I can call it just hit if I like to, or my hit, whatever. And what we now want to do is maybe we want to debug that. So debug dot, and now we can draw array. So we say draw array, open close parentheses, and what we want to take is maybe my array dot origin, comma my array, or no, in this case, yeah, it is my array dot direction. And maybe we're gonna give it a color, maybe color dot red, so we can see that maybe better. It's just for debugging purpose, so we can see if the array is present whenever we are calling the valid boolean over here, or whenever we are sticking onto a wall that we see that ray casting in front of us. Okay, so now we do the physics check. So we say if physics dot raycast. So we do an actual raycast and shoot that into the direction of my ray, or actually we shoot ray, which is going to be my ray. Then we say where do we want to shoot, or what do we want to use as a raycast, and we say out my hit or hit, depending on how you name it. And then we can define a length. So we can say maybe ray length. So the ray length, I don't have defined that yet. Maybe I want to do this up over here. And I want to have this not higher than 1. So raycast, or let's say float, ray length. You can also type everything down below, but if you need to do some quick changes, you can always go back over here and update it accordingly. So we're going to make use of the ray length of a 1 unit, basically, since we have a tile-based movement or grid-based movement based on 1 as a direction, and of course as the length of a tile or grid. And now we can check if we are hitting a wall or not. And since we need to return true or false, since we are actually requesting bool, we can, under that physics check, we can already say return false because we never hit anything. So we can, oh no, in this case it's true, sorry. We can actually return true because we haven't hit it something. So what we can actually do is we can now request if we were hitting a collider with a specific tag or whatever. There are hundreds of possibilities. In my case, I'm gonna take hit dot collider. And now we can call tag. You can also take a compare tag. I don't really care. People say this one is more resource heavy than the other one, but actually, who cares, you know? So what we are going to check for is maybe a wall tag. So we're going to create that in a second so we can actually check out if that is going to work or not. And if we are hitting a wall, then we want to return false. So return false, and our Boolean check for being a valid go or not is basically finished with that. Okay, and what we're gonna do next is we need to take this Boolean check into consideration. So what does it mean is when, let's see, when we are doing this distance check and we are able to move, then we want to do the valid check. So we say if, open close parentheses, valid. So if we have a valid turn, so it is returning true, only then we want to go to the next destination. So we update the destination in that particular case by taking the transform.position plus the next position. Also, what I want to set is the direction is equal to the next position. And we say can move is equal to false. So we are unable to move right now. Why is that the case? Because now we can only hop one field after another for, or in this particular case. Let's test it out first. With just without any wall, let the compiler run. If you have any typos, feel free to clean them up. So as you can see, I press once and I move from one area to the other area on that particular grid over here. Also, you can see this little ray is showing up. Sometimes, whenever we are doing this input, it is checking is there a wall or not. If you want to make use of the complete grid like it is, so you go always from the center, you might want to think about repositioning your character to the center of one of these particular grids, so it's later on probably easier to see or not too distracting. What you can do by that basically is you just need to position your character on 0.5.5 in the very beginning. You can also use snap settings by holding down Control key and snap it directly into the center, but you only can do that if your snap settings are all set to 0.5 in here already. So when we do that right now and I press play and I move one up, I'm gonna move to the center of the next grid, as you can see, and to the left, to the right, and so on and so forth, and we do the Boolean check. Cool stuff. So the next thing is maybe we want to test out something with walls. So for example, I create a cube, which is 1, 1, 1 in its size, and I zero this one out on all three axes except on the Y. I'm gonna maybe want to have this one on a 0.5, so it's lifted up half. Now we can position that and bring this maybe over here, so we are maybe not able to move through that little boxes, and I want to make sure that they are inside the grid as well, so that our character is not doing any fancy stuff because we are only looking one piece forward. Okay, let's try to move through these walls. Oh, we gonna have to tag them already, so I need to go to one cube, go to untagged, add a new tag, and we're gonna put in wall. Make sure you type this one 100% correct, like with a big W over here. Now we need to select those two cubes and tag them with wall. When I now press play and check this one out, that I go forward, like into the world axis forward. As you can see now, and here is a small ray casting showing up, meaning we are unable to move to the next point because there is an obstacle. And I can push the wall time, nothing will happen. But I can still move to the other ways. As you can see, I cannot pass that, and not even the other ones. Now we have one more problem. The problem is actually we are not unlimited moving again. We can implement that, or like whenever we are holding down a key, that we are going to do the movement or the move input. So instead of using get key down, we probably want to just make use of get key. So whenever we are holding down, we always update that accordingly, but we only do that whenever whenever the tile-based move input is going to be at a super slow or a super small distance to the current position. But yeah, that basically is everything about tile-based movement. So once again, you can now move from one piece to another. You cannot hold down that, but you can press rather quick, and as you can see, it's updating accordingly. So once again, if you want to make use of get key, I'm not 1% sure if we can also put this into this here, like into the W key. Maybe I'm gonna test it out with just one. So I comment this line out over here and see if I can make use of get key instead of get key down. I copy all of that input in here and just get rid of some line in between. Maybe like so. Maybe there's one, oh yeah, there's one parenthesis or one pair of parentheses gone. Nothing fancy. So instead of that, we're gonna take a get key, meaning whenever we are holding it down, then we are able to set the next position as well as the current direction and can move to be true. Probably this helps to keep on going, but I do not promise anything. So this is now only on the W key. So let's try that out. So I move once to the right, and when I now do that, I can tap it for short, but it is like overhopping always once. But when I hold it down, it is keep on going until it is reaching basically down the next position or the position above. So probably this is also something you might want to make use of. So instead of get key, you can also move with that stuff with get key down. I'm not sure if we can make use of an OR operator for this input as well. So you probably want to stick to one or the other. And maybe you want to do an extra check if a transformer position is basically same as the destination, only then you are able to get or go to the next position or update the next position. Basically, I think that should be everything about that. Maybe there's something I forgot here. Maybe I'm anyhow able to give you another possibility for using that or make use of that. Well, nope, actually not. The other ones is just unlimited movement, but we had that beforehand already, like whenever we are not checking for true or false, like if we are able to move or not. Okay, cool. So that's basically everything I wanted to cover in this little tutorial. So now you know how to go from one grid to the other. Once again, if you have a smaller grid like a half meter by half meter grid or whatever, you can actually reduce these numbers like a next position, a vector 3.forward, or in this particular case, whatever you are adding to it, like here, you are not using vector 3.right as the next position, but maybe you make it half, like you divide it by 2 or something. So it is always half the size. Or you define a grid, actually a movement parameter, and you're going to make use of that movement parameter, which you're going to add to your current position. So basically, once again, next position is always added later on in here to the transformed position. So in this particular case, you can say, okay, in here it would be like a new vector 3, 0, maybe 2.5, 0.5, and then 0 again into the forward axis. Or yes, I believe. And like backwards is going to be maybe a minus 0.5, and so on and so forth. Thanks a lot for tuning in. I hope you enjoyed this little live stream, as well as if you don't see it in stream, but in as a video later on. Thanks a lot for watching. I hope you enjoyed it. Yeah, feel free to come to octomangames.com if you have any trouble. I support you with creating your games with a small fee, of course. So if you have any requests or something like that, move over there to octomangames.com. Link will be, I believe, in the description below, so you can hire me and we're gonna create your game or actually update it or whatever, or I'm gonna help you with troublesome stuff for that. So again, thanks a lot for watching. I hope you enjoyed and I hope to see you in the next tutorial. Bye bye.